This is EECS203, Project 3, Group A. Today we're going to be talking about functions, specifically injections, surjections, and bijections. So if f is a function from set A, so this is our set A, and if to set B, this is set B, we say that A is the domain of f and B is the codomain of f. So this is our little f, and this is the mapping between little a and little b. Injection, that's what we'll start with. It's also known as one-to-one. A function is said to be injection if and only if f of a equals f of b, which implies that a is equal to b for all a and b in the domain of f. Yeah. So to show an example of injection, we'll map a to 4, then we'll map b to 5, c to 1, and d to 3. Now notice that f of a and f of b never point to the same y value. That is the entire meaning of injection. They never point to the same y value. Yeah. So basically, f of a is not equal to f of b if a is not equal to b. Here's an example of an one-to-one function. F of x is equal to x plus 1. And it's from the set of real numbers. Okay, so f of x is equal to x plus 1 is a one-to-one function because x plus 1 is not equal to y plus 1 when x is not equal to y, which is the definition of injections. So now we're going to start on surjections. A function f from set A to B, which is also known as an onto function, is if and only if for every element B in big set B, there's an element little a in big A with f of a equals b. A function f is called surjective if it is onto. So here's an example of surjection. So like if a maps to 3 and d maps to 3, c maps to 2, and b maps to 1, notice how each y value, each codomain is used from the domain to the codomain.
Okay. We're going to show another example to show onto function by using a graph of function y equals x squared. When domain is all the real number and then codomain is all the positive real number, if you're using a graph, you will see like this. So if you're looking at this value, y value, right here, it will correspond to the x, and all the y value at the end, you will have all the value over here. And this is the reason it's onto function.
So finally we come to bijection. Bijection is just a function that is both one-to-one and onto.
Here's an example of the bijection. The function is y equal to x cubed, and you could see from this graph here, this is one-to-one because for every a and b in the domain, we cannot gather fa equal to fb if and only if a equals to b. So as long as they have different value in domain, they will have different value in codomain. to show this is an onto function, we need to say whether every y value will get at least one corresponding x value. As we could say, the y value go from the negative infinity to the positive infinity, and meanwhile the x value in domain will go from the negative infinity to the positive infinity. Just like the graph, it will extend to all the points.
So this was our video, and thank you for watching this video. Thanks.